Welcome to another episode of libGDX-Graph devlog. In this episode, I'll show you how to make a Star Wars type hologram shader. So I start off with this basic pipeline with just background, graph shaders, UI renderer, and the end. And I also have this default shader, which basically draws whatever diffuse texture is with the UV coordinates onto the output. And I'll add here hologram new one. And let's get going. So let's make that window a little bit bigger. It's gonna be quite a busy graph here. So let's start off with so what I'm trying to go for is a hologram with like bands, horizontal bands on the hologram, one colored and with some distortions over time. I hope you'll follow this for a moment. So let's start off with the bands. So what I want is to have a sinus wave based on time. So actually not based on time. So what I want is a position in world coordinates, and I'll only take the Y part of it. So I'll split it, and I'm interested into Y coordinate because I want the bands to be horizontal. I will enter it into a sine function, which will give me values between -1 and 1. And I'll have to remap it because I want it between some specific values. So math value remap. As you can see, I've moved around the nodes in the menu quite substantially. So I want to go from, so the sine gives us between -1 and 1. And I want to have this, let's say 0.1, 0.8, and it's going to be used as an alpha value here. So there's not much change. That's because we are opaque, but once I switch to transparent, we are seeing some changes. The problem is that at the moment that the sine wave is just too small. So what we're gonna do here, we're gonna multiply it by a side property here. Let's call it band size. Let's go with default of 100. Add it here, and I'll multiply it with the Y value. That's because the Y value in this model is from -half to half. And the sign from this is indistinguishable almost. The values are just too small. So I'll multiply these two values together, and use the result here. Oh, now we are seeing the bands that I was looking for. Okay. Maybe I'll make them a bit larger, maybe 500. Yeah, that looks more like a hologram. So second part, what I want to do is to add the color based on the diffuse texture. So maybe I move this a bit further down to make more space for my graph. I'm working on being able to move multiple nodes at once, but I have not finished the code for it yet. So I want to do a color here. So we start off with diffuse texture. We'll take UVs, so coordinate of the texture from the model, and we'll sample them. And what I'm interested to, so if I just apply this here, let me choose texture. Okay, so I have this texture. I don't want to have colored. I want to have specific color. So let me add here a new color property, which is going to be color, named color. And let's go for the kind of blue, like in the Star Wars movie, like light blue. Add it here. And what I want to take from this is the brightness or the lumi of intensity of the pixel here. So if we now take the luma and we multiply it by the color, we'll have the intensity of this color as a result. So I'll multiply them and use it here. Okay, so we are seeing now we can modify it, and let's go for green. You can have holograms of different colors just with a property here. And now probably so this is already a hologram, but what I want to do here is to use this new input into the shader, which is the world position, which is used for distortions, so modifying the position of vertices of the model. So what I want to do is, from time to time, let's simulate something like there is a problem with communication from the device, between the devices, and therefore the hologram flickers for a bit, like stretches and squishes vertically. So let's start with position attribute in world coordinates, so we can immediately attach it here. Nothing changes because that's what exactly is being used by default. But what we want to do here is we want to add some distortions based on time. So let's use the time here. And I want to use it to get some randomness. I'll be using a noise. I'll use noise 2D. However, UV requires a vector 2, so I'll merge. So I'll pass the time into the X, Y will be 0, and I'll pass it to the noise. Okay, so I already have a noise here. Now I want to, so the noise is gonna be by default from minus 0.7 to plus 0.7. So what I want to do, I have to put scale here as well. So let's add here new value distortion noise scale with a value of 1. And then okay, so we have this part. Then what I want to do is remap it. So this value is going to be from minus 0.7 to 0.7 or whatever values what they are from the noise function. And what I want to do is I'm only interested in the upper part of it. So what I mean by this, if I have like a function going between -1 and 1 or -0.0%, I'm only interested in the top part. So when the noise goes above some specific value, and I'll call the value distortion frequency, which is basically how high above what the value of noise should be and above to create a distortion. So let's start with 0.65, which is close to the 0.7. So the distortion is going to be happening rarely and going to be rather short. So let's add it here. And I will use it as a remap of this noise function. So I remap this the values it will give me is between this. So the values accepted will be this and 0.8 or 0.7. And I'm gonna merge this into a vector 2. Okay, so I want to remap this from the distortion frequency, so in this case 0.65 to 0.1. So anything that's going to be below 0.65 is going to be negative, and all the values between 0.65 and 0.7 will be in the range of 0 to 1 after this remap. Okay, since I'm not interested in anything negative, I'll just clamp the result of this. It's gonna be in here, and I'll clamp between 0 and 1. So in here I'll have, as a result of this, I have values between 0 and 1, and most of the time value is gonna be 0. Because if they are below, if the noise result is below 0.65, the result of this is going to be 0. So from time to time, this will produce values that are above 0. Most of the time, it produces 0. Okay, so now what we want to do here is to, let's make a bit more space here. Let's now figure out how we want to distort it. I will do it based on time. Let's remove this. This is not needed. So I'll use the provided time, and here I'll introduce a new one, new property, distortion speed. So what I'll use for the distortion is the sine function of time, which basically is going to be modulating between -1 and 1. That will be squishing and stretching vertically the model. And the speed will dictate how fast this is going to be happening. If the higher the speed, the faster it's going to be moving vertically, it's like squishing and stretching. And if the lower it's going to be, then it's going to be slower and more visible. Let's start with maybe, I don't know, 100. And so I'll add the property here. I'll multiply the time by this, by the speed, and I'll take a sine function of it. Okay, so I have -1 to 1. That is going to be fluctuating based on the distortion speed. And now I will multiply the effect of this sine by the value based, so the distortion size. So distortion is going to be mostly 0, so this is going to be mostly 0, and from time to time it's going to go from -1 to 1. Okay, now another thing is how big the distortions we want to have. So let's add a new one. Let's call it distortion amplitude. Let's go with 1 by default. Add it here. So what we do here, we multiply these two. So it's going to be mostly 0. From time to time, it's going to be -1 plus 1 multiplied by the amplitude. And what we want to do, we want to take the position in world coordinates of the specific vertex. We want to split it because we are only interested in the y coordinate, because we want to change only y coordinate. We want to keep x and y the same. X and z, sorry, the same. So we take the y, we multiply it by the effect of this. the y coordinate, and we're gonna add this to the world position. So let's reuse this one. So we take world position and we take the y here, that is multiplied by mostly 0 from time to time. It's going to be -1 to 1, or minus whatever it's here to whatever it's here. And we are gonna have to make because this is a vector 3, we have to merge this as a y coordinate. So x is going to be 0, z is going to be 0, and y is going to be mostly 0, sometimes bigger, sometimes a bit smaller. Okay, and this is what we're going to be using for the world position. So no errors, and let us observe for a moment this. Yeah, it's fluctuating. Maybe we're going to make it a bit smaller amplitude because it's going a bit too much. Maybe a bit smaller than this. Okay, that's what I wanted to go for. Okay, so now let's use it in the libGDX program. So I downloaded this great model of Starship here, which is suitable for our hologram model. As you can see, by default, it is using the default shader. But when I click this button, I'm gonna turn it into a hologram, which is gonna flicker because of some distortions in the ether. Okay, I hope you find this useful, and if so, please like the video, as it will let me know what content to make. Please also subscribe to the channel to be notified of any new videos. Thank you for watching, and bye.